Unlike Leon, I do have to say some things about Shlomo. I don't think I could come here to an event in his honor without doing that. So I'll just get into it. You'll excuse me that I'm reading. I just don't think that I could do this without reading it. I met Shlomo and his family in 1978. Shlomo and his family received this from me, actually, but many of you may not have. I met Shlomo and his family in 1978 when I was on my first sabbatical in Israel. I didn't come to work with Shlomo. I came to work with his thesis supervisor, Amiram Karmon, who I thought was in Jerusalem and may have been, I can't remember, may have been and then moved to the Technion. I didn't want to go to Haifa. Had nothing against Haifa, I just wanted to be in Jerusalem. And he suggested that I go and work with his student, who was at the time, I think he just received his MA, was working on his PhD, but he was already head of the electrophysiological laboratory at Hadassah, where he set it up, and he thought I would enjoy working with him. And I did. We became fast friends, and the friendship extended to our families. We stayed at each other's houses, spoke often when we were apart, reveled in each other's successes and family celebrations. So this is what Shlomo looked like in 1978-79 when I was on sabbatical with him. My son also came when he was studying, took a year abroad, and worked in Shlomo's lab in 1996 when he published his famous N170 paper. I don't know if Shlomo had anything to do with it, but my son went on to become a psychologist too, and remembers those years very fondly. I came back in 1985-86 to spend a sabbatical here too, and in case some of you can't recognize who's there, let me point out some of these people. This was next door at the Machon, the Institute for Advanced Studies. This is Shlomo. This is me. There are a few other people, Asher Koryat, Israel Nachshon, Sunny Kugelmass, Harvey Babkoff, Carlo Milta, Eran Zaidel, Elchanan Goldberg. It was a terrific group. God, I've suddenly forgot her name. Zaidel's wife, what is it, Miri? Dalia Zaidel. Michael Corbelis. Anyway, it was a terrific group. We were going to work on laterality that year because that's what we were all interested in. As I said, we spoke often when we were apart, reveled in each other's successes and family celebrations. And when I would come, took vacations together and supported each other when things did not always go well. We were never rivals, except in two domains. One domain was in who could complain more loudly when felt we were treated unfairly by nasty reviewers. And the other I'll mention in a second. I thought the world was Shlomo, the world of Shlomo. There was no one I knew who relished life as much as Shlomo and devoured it. I speak for my whole family and my wife Jill, who would have liked to have been here but couldn't because she had to stay behind to take care of her mother, when I say we all feel sad and bereft. So when we arrived, we would show up, stay with the Bentins in Mevaseret, stay with the Bentins in Mevaseret, be with their celebration. I think this is Shlomo and Itamar. This is Ido and Noam. I arrived in 2008, shortly after Ido was born. That's Noam next to him. We celebrated Hanukkah together in Shai's house, where I stayed this time. And we vacationed together this past year. In October, we went to visit Shlomo and Miri in Berkeley and went up the California coast. And then saw each other again in May in New York. Oops. This is the last thing that we were rivals about. We would talk about our grandchildren, and these are them, taken recently. I have 3, and Shlomo said, I don't think you'll catch up with me there, Morris. They have, I think, 7 and counting. We have 3, and we may have stopped counting. And I told him, well, I don't know, Shlomo, if I have a few more kids, maybe we'll have more grandchildren in the long run. So in the land of Avraham and Sarah, this may not be the miracle that it might be someplace else. Freud more than once implied that the ability to work and love is a mark of mental health and essential to happiness. In this regard, Shlomo was in robust health and happy beyond measure. He was truly blessed. We all know of Shlomo's capacity for work. Shai mentioned some of that. I consider myself and most of my colleagues as very hard workers. But in relation to Shlomo, I sometimes felt all of us were not working to our capacity. But then I had to remind myself that our capacity did not equal Shlomo's. When I stayed at Shlomo and Miri's house, which was often, I would go to bed at what I considered to be a late hour, yet Shlomo continued working at his computer long into the night, and then would greet me in the morning for an early breakfast and head off for more than a full day's work. And this is, I'm not saying this in an exaggerated way. You think I may be exaggerating. This is the awful truth. Though we tend to call people who work so hard workaholics, as if they suffered from an unfortunate addiction which needed to be cured, I do not believe this term applies to Shlomo. I don't think he was addicted to work as much as he was passionate about it. And when passion intervenes, when work is not an escape from life, as addictions are, certainly not in Shlomo's case. As Freud might have said, work was an affirmation of one of the joys and rewards of life. Considering how much time we devote to our work, who among us would not want to love our work as much as Shlomo loved his? His work took him to many places where he sojourned while he was on sabbatical or extended leave and developed collaborations and friendships in New Haven, San Diego, Toronto, Lyon, Berkeley, to name some of the places. If his collaborations with colleagues at those places were anything like those with me, then I can say that they really got sweet deals. Shlomo was generous to a fault with his collaborators. I remember one project in which we used electrodes on the skull to measure brain waves associated with memory. I use this non-technical language advisedly. I really was not familiar with the technical aspects of the study and did little but help design the study and edit what Shlomo had written. Nonetheless, Shlomo gave me full credit for this research. I never talked about it, presented it anywhere, not because I wasn't happy with it, because I was afraid that somebody would ask the question, where were the electrodes placed? And I would have to answer, in Jerusalem. You'll have to talk to Shlomo if you want to know the coordinates on the skull. But tonight I'll make an exception, and I'm finally going to talk about that study at the end of my talk. The credit I received was not unusual. In speaking to Shlomo's students and to Shlomo about them, I learned he was as generous with them as he was with me. I cannot remember a bad opinion that he had of any student, and we talked a lot about them, or any student for whom Shlomo did not extend himself to find positions when he or she was ready to leave the lab. The number of students he had and their successes, gratitude and affection attest to his being a devoted and caring mentor. When he took over the editorship of Neuropsychologia, he read and commented on every one of the papers on which he was an action editor. And these ran into the hundreds. This practice, and maybe I'm offending somebody by saying this, but I hope not, this practice has been abandoned by every neuroscience editor I know because the workload was too much. Best of all, for in Shlomo's case, his reviews, though sometimes critical, always were thoughtful and respectful. It really was an astounding achievement. Shlomo's capacities for work was matched, if not exceeded, by his capacity to love, which extended to Miri, his sweetheart and love of his life from the time they were teenagers, to his children, Shai, Einat, and Ayala, who are in the audience, to their spouses, who are also in the audience, and their children, who are not, but I left the picture on for you to see them. Also to his friends, to colleagues, and to every aspect of his life, from food to art in all its forms and to travel. Jill and I felt embraced in the circle of love and basked in its warmth. Being greeted by Shlomo and Miri at the airport in Tel Aviv made us feel at home immediately. I can still see the look of delight in both their faces and eagerness on Shlomo's face to talk about whatever was going on in his life at the moment, feel his hugs and kisses, and hear the conversation about family, friends, and work that began even before we entered the car and did not stop until we reached their house in Mevaseret, where we felt less like guests and more like members of the family. He brought the same delight, exuberance, and enthusiasm to all his activities. On his various sabbaticals, he immersed himself in the culture of the places he visited. While in France, he made a point of learning to speak and read French fluently, priding himself in reading, if I am not mistaken, many of Alexandre Dumas' long novels in French. I believe he also learned Italian to go along with his native Romanian, Hebrew, and English. So one thing that I didn't say is we both have a bit of a common history. We both were born in Romania. We both emigrated to Israel. I when I was 4 and stayed here till 7 when my parents left. Shlomo stayed, came a little later. And we both shared similar interests in our research. When in Toronto, he learned to ski, so he visited us too and made a sabbatical there, and developed a passion for that. He began to attend regularly a conference in Bressanone in the Dolomites in Italy, which combined skiing during the day with paper presentations and discussions in the late afternoons and evenings. This conference and its aftermath turned also into an occasion to go on ski trips with his son Shai, which they did regularly. And anyone who knows Shlomo cannot but marvel at his passion for food and wine. Even on an extended trip through the wilds of Alaska, that passion did not, to our great surprise, Jill and mine, did not seem to recede in the least. Staying with Shlomo and Miri meant that we could eat better and sometimes more lavishly at their house than in restaurants. In the beginning, I warned Shlomo that he need not serve his best wines to me and Jill, as the fine distinction between good and excellent wines would be lost on us. I gave up doing that when I saw that it deprived him of the delight of sharing the wines he stored in his cellar with good friends. And this attitude pervaded all his experiences. He wanted to share his love of music, of literature, photography, and art. When we last vacationed with each other in New York, the end of May, the beginning of June, we went to a play, a jazz club, restaurants, and museums. Though he let us know very clearly, let us meaning me and Jill know, that he would not go to a museum that focused, we wanted to go to the Frick, he would not go to a museum that focused on art prior to the Impressionists. Who knew he had such strong opinions about that? Though I shouldn't have been surprised. Shlomo had strong opinions about lots of things. But they were informed. He could argue his case. In a recent book I read, there was a phrase which struck me as true, even more so now than when I read it. The measure of love is loss. When Chaim Potok, a favorite author of Shlomo's, died, Shlomo said, "I am sad that he died, and I am also sad for myself." Because I won't be able to get pleasure from reading new books of his. Jill and I feel the same way about Shlomo. As I said before, I believe Shlomo's life was blessed, though it was too short. And those who knew him shared that blessing. Jill and I miss Shlomo terribly. Thanks. And now I'll get on. It seems crazy to give a talk. But I don't think I could have given any talk while having those things in my mind. So maybe with that past, I could talk about the things that Shlomo and I talked about that I would say in this celebration of his life, of his prize, which was supposed to be rather than the celebration of his life. So I'll speak about the area of expertise that I have. I do work on face recognition, but as I said, we weren't rivals. And I felt somehow it was inappropriate for me to bring my work while somebody talked about Shlomo's work. So I left faces aside until the very end, when there's a confluence of some of the things that I'm interested in and some of the things that Shlomo is interested in. So we thought I'd talk about episodic memory, and it seems fitting now also because episodic memory does link us to our past, our present, and also our future. The problem I'll talk about is one about memory consolidation. It's one of the oldest problems in cognitive neuroscience. It existed before cognitive neuroscience existed, and its scientific history dates back to the 19th century, though people probably knew about something like this for a long time before that. Memory consolidation is the time and experience-dependent process by which newly acquired memories become stabilized. Consolidated memories are relatively immune from disruption by behavioral interference and by amnestic agents such as lesions or drugs. We never knew where consolidation happened or what structures were very important to it until Brenda Milner and Scoville published their seminal paper in 1957. The star of the paper was HM, though there are 10 other patients in that paper. HM, his name is Henry Molson. I mentioned in the last lecture before he died, you couldn't give out his name. I worked with him once. So I would refer to him as hippocampal man. Because he had his hippocampi excised, you can see the lesion here, by Scoville, in order to cure intractable epilepsy. Epilepsy that was intractable to drugs, epileptic seizures. And in that regard, it was a very successful operation, but left HM amnestic. And then his amnesia had interesting forms. He was able to talk well, he was able to perceive well, his short-term memory was fine, and his remote memory seemed to be fine. That is to say, his memories for events that happened long before his surgery seemed to be okay. He just had a period of about 3 years where his memories were wiped out. And as a result of that, people thought the hippocampus, the area that was crucial, that was removed in him, but not so much in any of the other 10 patients, was crucial for consolidating memories from short-term into long-term. And after it did its job, the hippocampus was no longer necessary. Where is the hippocampus? I know I'm speaking to some neuroscientists, but I imagine there are some non-neuroscientists in the audience. So this is the hippocampus. It resides in the medial aspect of the temporal lobe. So if you open your brain and let's say you had an axe and somebody hacked your brain down the middle, you'd have two halves that look like that with the hippocampus exposed over here. It's called the hippocampus, as many of you may know. This is the way it looks like in the brain, and it has a shape of a seahorse, a hippocampus with different portions, the head, the body, and the tail, which we now know probably have different functions. Here it is from another point of view. The hippocampus is over here. It's connected to the rest of the brain by one of these pathways called the fornix, and extends down into the diencephalon, the region below the brain. If you're to lift one's head up like that and look at the brain from the underside, this is the hippocampus, the amygdala, and structures that feed information into the hippocampus. The parahippocampal cortex and the perirhinal cortex feed their input to the entorhinal cortex and then into the hippocampus. Here it is again in a coronal view, that if your axe hacked you down that way, this is what it would look like. The hippocampus was believed to be a temporary memory structure that is needed only until memories are consolidated elsewhere. That's what HM seemed to have taught us. And so you'd have something like this. Initially, when you experience an event, You need the hippocampus to recover it if the event is of a certain type, and I won't be too technical at this moment. Some events don't need the hippocampus at all. But if it's a complex event, like coming to a lecture or knowing what you did during the day, if you didn't have a hippocampus, you wouldn't remember it beyond the very little bit of time after the event occurred. But it was believed that the hippocampus begins to relinquish its function to the neocortex with time, so that after a certain period of time, you can recover that information directly from neocortex, as seemed to be the case with HM after 3 years. So the first 3 years, he needed of an event, he needed the hippocampus. After that, all his memories were non-hippocampal ones. I was on sabbatical with Lynn Nadell in Arizona, and I was asked by Misha Mislobotsky, Zichrono Livracha, to come to Israel and talk about consolidation and the hippocampus. I had said I'd never worked on consolidation in the hippocampus, and he said, doesn't matter, we'll get you here to Israel, I'm sure you can learn something about it. So I said, okay, it's easy to buy me. We started looking into the literature and discovered that the hippocampus seems to be much more crucial than people considered. And it doesn't have just a temporary memory function that people had thought, that it's needed only until memories are consolidated elsewhere in the brain. It seems to be crucial forever for some kinds of memories. What kinds are they? So if we look at autobiographical memory, we can divide it into two types. Semantic memory, that is knowledge that you have about your friends, places you visited, schools you attended. So HM, for example, if you ask him where he went to school, who his parents were, he knows all that stuff, easy. But there's another kind of memory, an autobiographical episodic memory, where you have to go back and describe in detail, essentially relive the past. Tell me about the first day of work in your life. Tell me about the first kiss you ever had with somebody who wasn't a parent or a sibling. Tell me about your very first date you went on. And you could go on like that, and eventually you'll find a memory that people have, and they can describe it in exquisite detail as if they were reliving that event. For these semantic memories, you don't need the hippocampus. What we did was look at people in this study who had unilateral temporal lobectomies, the same kind of lesion that HM had, that the surgeon Scoville took out his hippocampi because seizures started over there. After Scoville made his mistake, and Penfield made some mistakes like that also, nobody would take out the hippocampi bilaterally, but they would take them out unilaterally, because you had the other hippocampus to stay on. Why would you take them out altogether? Because you have an epileptic focus over there and makes life very disruptive. So you take out parts of the hippocampus, either on the left or on the right. Now, if you would ask people about autobiographical events, where they went to school, who their parents are, and you'd ask about these events that pertain to childhood, early adulthood, or recent events, they could do that without a hippocampus. Those are facts that they had about themselves. However, if you wanted to ask them in detail, tell me about the first time you kissed somebody other than a relative. Tell me about your greatest triumph when you were a child or in high school. If you didn't have a hippocampus, you couldn't do well. And you get scores for how many details you can remember. And you could see we refer to that as episodic memory rather than semantic memory, because you have to remember episodes. And you could see that extending all the way back to childhood, controls perform much better than patients whose hippocampi were removed, even only on one side. Now, it could be many of these patients had these hippocampal problems from early childhood. So we wanted to divide them into two kinds of patients. One kind who had seizure onsets from the hippocampus, like HM, that were late. They started after the age of 16, and those that began in childhood. And you can see that even with late onset seizures, memory long before the seizures began, is already impaired, all the way down to the very first memories that people had. So the hippocampus is crucial, and it isn't something that you can dispense with after a little while. So with Asaf Gilboa and Shana Rosenbaum, we found, and the help of Amir Poreh, who was in Israel at the time, we found a person who had a very late lesion, not these epileptic patients with unilateral lesions, but someone who had a lesion caused by a surgeon late in life. This person had a colloid cyst, a cyst growing inside the third ventricle over here, and it was starting to expand, and it had to be removed. And otherwise the person would have died. And in removing it, they cut the output from the hippocampus that I showed you earlier in that area called the fornix. So this is what a normal fornix looks like. This is what happened to this patient. There are no fornices here. The rest of the brain is virtually intact, but the hippocampus is isolated from all of it. He looks exactly like the patients that we saw before who had large hippocampal lesions. His remote memory is fine for things that we call semantic memories or not true autobiographical memories. So he remembers faces, he remembers famous events going back 20, 30 years before his operation, but personal events he can't remember. There's a picture of him at the brit of his son, and he knew it was a religious ceremony. He understood what it was, but he couldn't remember that it was his brit. There's a picture of him that we showed him where he's on Masada because he was inaugurated into the, I think, Air Force or Army. He recognized what it was. His semantic memory was fine, but he couldn't place himself at that place at that time. And the amnesia extends for the entire lifetime for these personal events. We wanted to test this a little further and developed an autobiographical memory questionnaire. Here's what we did. We asked people to tell us memories. I used to play badminton with this girlfriend. Tell us a memory that happened a long time ago. So this is one that, a study that we did with Brian Levine. And this is the detail that we get. I used to play badminton with this girlfriend, and I was very envious of her looks. We used to have lots of fun. However, one day we went from one building to another to get to the badminton court. There was quite an expanse, and it was wet and slippery, and she suddenly slipped and fell. You can read along with me. I'm trying to read it quickly because I'm aware of the time, but it's really rich in detail. And we scored it according to the kinds of details that we have. Episodic details are details that are peculiar to that event, to that single episode. External details are more things that you generally know about the event rather than refer to things that you've experienced. So we code it. Here are the semantic details that are things that are ongoing. Used to play badminton. The girlfriend wasn't peculiar to the episode. I was very envious of her looks. That also wasn't peculiar. But some things are peculiar. It was quite an expanse. It was wet and slippery, and she suddenly slipped and fell down. It was all kinds of contortions and peculiar movements, and I was unable to hold back my laughter. All of these are peculiar to that event, and I hurt her feelings so badly that she never spoke to me again. I imagine, a very good friend. Here's a description from HM, that person that we described before. How are his descriptions of something very important, much more important than this tennis match? So, Sue Corkin asks him, did you fall in love once with anybody? Yes. Okay, tell me about it. Well, just how you felt and everything and the ways it could be, and they would fall for you and you still didn't know. That's it. That's all we get from him. Can you tell me more what you first felt when you were falling in love? One specific event? No. You can't think of that? Can you think of one specific event lasting for several hours from your early childhood? Can you come up with anything like that? HM said, no, I can't. In fact, there is one event for a lifetime of 25 years or so before his operation, and he died in his 80s and never got another event. That was it. But he knew lots about himself, except it wasn't that kind. When we do a fine-grained analysis of autobiographical memory, we want to know what aspects of memory are crucial. Is it the uniqueness of the event, details specific to the event, the gist of the event, the perceptual aspects of it, temporal and relational coherence of the memory, subjective immediacy of the memory? These are all kinds of things we could ask about a particular memory, or any kind of episodic memories that you might have. When you first fell in love, when you first met your spouse, or a girlfriend that you met and didn't become your spouse, or a boyfriend in the same position. We have these exquisite memories, and we can remember a lot of things about them. What aspects of the memory are dependent on the hippocampus? And we did this by testing lots of patients, not who had these large bilateral lesions, but had only small unilateral lesions, only on one part of the brain. What they forget are the internal details of the event, those things that are perceptual so that you can relive it. They give rise to an immediacy of subjective experience and even changes in syntax and reference to reflect it. So when people talk about events like this, they will refer to them in the past, and without their knowing it, and we record this, they immediately switch to the present and talk about the past as if it's in the present because it's so compelling. And people without a hippocampus or even minor hippocampal damage tend not to do that very much. We also have neuroimaging evidence to this effect. Asaf Gilboa and collaborators and I showed people photographs that a Confederate took from their family albums. They hadn't looked at these for a while. And this is a photograph of the self from their album, and this is a photograph from another person's album as a control. And they had to imagine the event that occurred when this photograph was taken. And here, relive the event that occurred when this photograph was taken. And this one that didn't pertain to them, they just had to imagine what may have happened. And what we find is that for their own photographs, even if the photographs were taken 20, 30, 40 years before the subjects were being tested, they were put in a scanner and we measured the activation of these areas. What we find is that the hippocampus, in all cases, in this case on the left more than on the right, in all cases is much more active for photographs of their own life than for photographs of someone else's life, even though they may not have seen the photograph for a long time and it pertains to an event long ago. This is what the hippocampus looks like in sagittal view. That is to say, if you split your head open like that and open up each side. And the interesting thing is that memories are distributed differently along the hippocampus, with recent events crowding in the anterior portion of the hippocampus, and remote events, that is their activation, distributed along the length of the hippocampus. And we'll have a little bit more to say about that right now. So a student, Jordan Popenk, actually wanted to see, is one part of the hippocampus more important than the other in these kinds of memories, in terms of the size of the hippocampus, not its activation on a neuroimaging study, but actually how big it is. And he compared the size of the posterior part of the hippocampus compared to the anterior part of the hippocampus in a number of subjects who participated in our research on functional neuroimaging of memory. Recollection is the ability to re-experience an event in great perceptual detail. And what we find is that the posterior hippocampal volume is a good predictor of how much recollection we have of the past. The anterior hippocampus actually seems to go against it, is a poor predictor or a negative predictor. In other words, how big the posterior hippocampus is will determine how easily it is that you can and in what detail you can remember a past event richly, as opposed to merely knowing that it occurred and saying one or two facts about it. And the reason is that the posterior hippocampus, whoops, I think this is it, that's the end. All right. The reason is that the posterior hippocampus, the part in blue, connects to all kinds of perceptual areas that allow you to re-experience the event. It's okay. That allow you to re-experience the event more richly. Whereas the anterior hippocampus tend to be associated with more conceptual areas in the anterior part of the brain. What about spatial memory? A lot of people think that the hippocampus is involved in spatial memory, not these kinds of memories that I talk about. But Lynn Nadell, my colleague who did the same studies, published a paper with John O'Keefe in 1979 called Hippocampus as a Cognitive Map. Thank you. I wonder if I can manage to kill this one too. And maps are schematic representations of space that retain information about distance and direction among salient landmarks akin to gist or semantic memory. But they thought that the hippocampus was crucial for you to be able to navigate. So any of you come here, let's say, and you want to find your way around this campus, you're using your hippocampus to navigate in this campus. Without a hippocampus, according to O'Keefe and Nadell, you wouldn't be able to find your way around it, even if you had been here many, many times before. Other views of it is that it's scenes that are important. Scenes are rich reconstructions of spatial locations akin to episodic memory. And McGuire, Hassabis, and colleagues, among whom is O'Keefe, had a different point of view than theirs. What could we find out about that? Well, we took this one patient that was really very much like HM. He had large bilateral hippocampal lesions, and asked him to sit in front of a piece of paper. And we said, okay, this is your house at this point here. And this is, I can't see it from here, I don't know, let's say it's a shopping center. I want you to, in this piece of paper, draw an arrow from your house to the shopping center so that the distances are right. He didn't have the arrow, it was a blank piece of paper, and we only gave him a dot. He was sitting in his living room. He didn't see anything else outside, but he knew the neighborhood very well. And his arrows were incredibly accurate. This is how it goes. This was his arrow. This was his mother's arrow. This was his brother's arrow. He was as accurate as anybody without a hippocampus. We didn't think hippocampus was necessary for these kinds of spatial maps that O'Keefe and Nadell did. And we then, however, had him sketch a map of his neighborhood. This is the patient KC with large bilateral lesions. This is his brother's maps of the neighborhood. These are his. So he knows all the major landmarks and knows the location to them, but some of the landmarks are missing. Some of the places are missing because he can't imagine them in great detail. So what we found out based on that is that KC and another patient that we had that was the same demonstrated preserved spatial memory for a neighborhood learned long ago, consistent with preserved schematic or semantic memory of events in one's life. However, what they were impaired at is remote memory for spatial details. What did the houses look like? What would they expect to pass along the way, not just to have a map? And indeed, Shana Rosenbaum and I, and other colleagues, decided to try the same test in Toronto. So this is a map of Toronto, of downtown Toronto. It covers about 2 square miles. And we asked people to navigate from one place to another in their mind's eye to what things would they pass along the way, a whole host of different navigational skills that was required. And we did this to normal people, that is to say who were not brain damaged, put them in a scanner and wanted to see if the hippocampus was active while they're imagining navigating through Toronto in these different ways, which it should have been active according to O'Keefe and Nadell if the hippocampus is needed for that. And we found activation in lots of areas. Retrosplenial cortex, for example, was the most active area. We found it in really tons of areas, parietal cortex, inferior parietal. We never found it in the hippocampus. We found it in the parahippocampus, but never in the hippocampus. The hippocampus is silent. because we remember space in its sketchiness. We remember just enough to be able to go around and navigate in it, and we don't need a hippocampus to do that once we become very familiar with an environment. What we won't know is being able to imagine what that environment actually looks like in our mind's eye. But it takes a while to develop that. So with Marnie Hirschhorn, we took undergraduate students who were newly arrived to the University of Toronto and didn't know downtown Toronto very well. They were just getting to know it. In those students, during their first year at the University of Toronto, the hippocampus was very active. This is it here. By their second year, there's no more hippocampal activation while they're imagining going through Toronto. The hippocampus relinquished that function to other parts of the brain, probably parietal cortex, parahippocampal cortex, retrosplenial cortex. So you need the hippocampus to acquire it, but within a year, you can dispense with it and still navigate more or less well in the areas that you know. Whoops. We also did another thing similar, and maybe it's not worthwhile telling it right now, but I'll do it since it's up. We asked people now in the lab to describe in detail how they would get from one location to another and describe everything that happens along the way, everything they see. Now what they're describing is scenes. They're not just describing a route, how to get from one place to another, but what they'd actually experience in one place to another. And we correlated that with a test that's very sensitive to hippocampal function in the short term, where you put objects on a tray, have the people look at those objects for a little while, remove the objects, and then 5 minutes later ask them to place it back on the tray. It's nothing to do with spatial navigation as such. But what you could see is that the closer they are, the farther away they are in the tray, let's see, is this the right? Mean displaced on the tabletop. I think I got this graph should look like that, but okay, so let me tell you what it is that I think it should be saying, is that the better you do on this hippocampal test, a tabletop test, the more details you can remember about the elements or aspects of your environment that you passed along the way. Navigation in downtown Toronto, this is now coming out in 2012, where we asked people, okay, imagine a place over here and another place over here. Which one is further away from the midline? So places that are close together, tell me how close together they are. Where they're far apart, tell me how far apart they are. Or you can say, okay, here are two places. Which one did you visit more recently that requires some episodic memory? And what we found is if they have to remember an event that happened at a particular place, the entire hippocampus gets activated on the left and a certain part of the hippocampus on the right. But if they have to simply know something about the location of these items, they don't need the hippocampus very much until the detail is incredibly exquisite. And hippocampal activation drops with the number of years that the people lived in Toronto, suggesting the hippocampus isn't always involved in the spatial navigation. It's important for recreating an event. So with Gordon Winokur and Lynn Nadell, we came up with an idea that describes these functions. It's the multiple trace theory and the transformation hypothesis that says as follows. Initially, memories are closely tied to the context in which they were experienced. These context-dependent episodic memories are formed in the hippocampus, they reside in the hippocampus, and the hippocampus is always needed to recover them. Over time, with support of the hippocampus, episodic memories are transformed into schematic or semantic memories that are less tied to context and capture only the essential features of the experience. Statistical regularity is extracted and/or memories are incorporated into pre-existing schemas, but these lack lots of detail. Semantic memories are represented in neocortical structures independent of the hippocampus, and the hippocampus isn't needed to recall them. Now, some of you in the audience may ask, what does this tell us about rats? And why may you ask that? Because in the humanities, man is the measure of all things, but in neuroscience, it's the rodent. And if you can't show it in the rodent, then what good is it? So do the rodents behave like this? So Gordon Winokur and our collaborators tried to find out, does the hippocampus have this extended function in rodents? Now, we don't know how to deal with episodic memories in rodents, but we can deal with exquisite spatial memory that seems to have an episodic-like character in them. So here's a maze that Gordon devised. Not devised, it's used, it's a cross maze. So let's say the rat is placed over here, and he has to learn to go north, let's say, to get a yummy. And this is a maze that's in a room with all kinds of cues. The maze would be placed in a room not quite this big, but in a lab room so that the rat could orient himself according to the environment. What we find in this test is that if we make a lesion 0 days afterwards, 6 months afterwards, or 9 months afterwards, I think Gordon even extended it out to 14 months afterwards. Rats only live about 25 months. They're impaired at every point in comparison to controls. Rats can't learn a complex environment because they lack an episodic-like memory for rats, just as humans do. There's another kind of memory, however, and it's called contextual fear conditioning. The rat is put into a cage in a room with lots of cues, and you shock the bejesus out of the rat. Not quite, but it's not a pleasant experience to the rat. And what does the rat do? The next time it's put into that cage, the rat freezes. It's called contextual fear conditioning. And what Gordon found out is that in controls, they spend a lot of their time freezing, even if they're tested 1 day, 7 days, or 28 days later. In rats, however, who've had hippocampal lesions after the experience, they don't freeze at all if the lesion is made 1 day later, but by 28 days they stop freezing also. They freeze as much as controls, suggesting that by 28 days that very same memory was now consolidated outside the hippocampus. And this bothered us because it went against our theory. Well, that's not the only reason it bothered us, but that was one of the reasons. We thought these rats should also freeze. And we reasoned what's happening in this case is that by this time the rats have forgotten, this particular room, and now they have a generalized room in their mind so that it's no longer specific. It's no longer an autobiographical memory for the rat, but more like a semantic memory. So we trained rats in this room and either tested them in this room or in another room. And we did this early or late after testing. And these are control rats now. They have absolutely no lesions. And what you can see is that at short delays, if you shock them in one room and test them shortly thereafter, if you test them in the very same room, they will freeze. But if you test them in another room, they say, oh yeah, I remember that room. This one's safe and I won't freeze. But if you wait 28 days, then both rats freeze. Why? Because the rats only remember the generalities of the experience, not the specifics of it, and the hippocampus isn't needed for that. As memories become generalized or schematic, they become independent of the hippocampus. Can hippocampal dependence be restored? So we have reminders and reconsolidation. So the rats are placed in these rooms again, and they could be reminded of the room by being placed in it a second time prior to the lesions. And what we find now is that in the control rats, here they are, they'll freeze in one room if they're reminded by it at 28 days, but not in the other room, just like at the very beginning. So they'll freeze in the room where they got the shock if they're given a reminder of it, but not afterwards. If they're reminded in another room, it doesn't seem to make a difference at all. However, with hippocampal rats, even though by 28 days they wouldn't freeze in that room if they weren't reminded of it, once they're reminded of it, that memory becomes hippocampally dependent again, and when you lesion them, they stop freezing altogether. If you use the other room as a reminder, well, that doesn't activate the initial memory, and they're fine. We are very happy to hear that some work done not at the Hebrew University, but at Stanford, but by Goshen, who came to the Hebrew University, confirmed our ideas that indeed the hippocampus is necessary to reactivate memories, and very elegant studies of hers, to reactivate memories in ways that suggest it's always necessary, at least for a while, even for remote memories. But we saw that HM and KC, our other patient, could navigate quite well in their own neighborhoods if they had lived in them before. Could we replicate that with rats? So Gordon constructed a rat village. So rats are given time to spend in this village and visit these little enclosures around it. What are in these enclosures? Well, there's food in one, there's water in another, there's a running wheel in a third, and in the fourth one, there's a female rat that this male rat would like to get to know. Over time, they actually learn this. They spend about, let them spend a long time in there. Then we found 2 weeks was sufficient. And then we test them. How well now could they get, after they've been starved for 28 days, for about 24 hours, we see how quickly they can find their way, let's say, to the food bin. And rats with hippocampal lesion take a long time to find their way, and they never get to be as good as control rats. That's if you make the lesion before they've had the experience. If they've been in that room for about 14 days, hippocampal rats perform just as well as control rats. They've acquired the memories, they no longer need the hippocampus, and now can recover the information easily that way. It's getting late, so let me get on to the last part of the talk. If you have questions about that technique, I'd be happy to answer them. So why do we need these detailed representations of personal experiences? In fact, why do rats need them? We need them for almost everything. We think of lots of these tasks as not requiring the hippocampus, such as semantic memory. For example, knowing who people are and calling them by their proper names. Categorical perception of faces, distinguishing between faces as they become morphed, seems to require the hippocampus. Priming requires the hippocampus. Navigation and scene construction in humans and rodents. To be able to use your imagination properly. Planning for the future. You can't plan for the future if you don't remember your past in detail. You can remember lots of things about your past, but if you want to plan in detail about the future, you have to have a detailed memory about the past. I won't talk about any of these things, but stick to just the first one, because here it is that Shlomo's work and mine converge again. There are two kinds of memories you could have about an individual that you meet. You could know lots of things about them, but have no memories associated with them. So about this person, you might know that she goes to barbecues, has love affairs, cycles, and swims. About this individual, you know also lots of things that are in general, but as I mentioned in my talk yesterday, this individual stole your girlfriend from you. So there's some memories that are really detailed, especially what he did at that party when you lost that girlfriend. And you ruminate about it, and so you have many of those memories distributed in your hippocampal complex. Does this come into ordinary life? How do we name faces and objects? So Shlomo's work concentrated on understanding what kind of a representation a face has. This work that I'll be talking about, it's very short, has to do with how we process faces when we actually name them and have probably some autobiographical information about them. Will the autobiographical memory neural network become engaged when we're retrieving the names of people? One of the terrible things about becoming older is that you forget people's names. And it's not just becoming very old. It's something that begins in the 40s and gets exacerbated. And what we discovered in our work with Nigel Gopi and others is that it's not related so much to semantic information that you have about the individual, what you know about them, but related to the recollections that you have about the individual, what particular events you can remember about that individual. So for example, you all know who this is, but you also probably all have very strong episodic memories, autobiographical memories related to this person. And what we wanted to see in this study is whether people that you name behave differently from people that you can't name in terms of the regions of the brain that you activate. And in particular, we hypothesized that people that you name are those about whom you'll have recollections, and then people that you name will activate the hippocampus. If you can't name a person, chances are you don't have good recollections about them, and the hippocampus won't get activated. So we looked at faces versus objects, and the items were matched on familiarity, how familiar the face was by the individual, and the objects were also matched on difficulty. How difficult is it to conjure that name? So here's Ramsey, the chef, the Iron Chef, and you press a button. You're in the scanner now. You're seeing these pictures one after the other. After you see the picture, the person, you name it in your mind's ear, let's say. Then we test them outside the scanner to make sure that the answer they gave was the correct one. You say, oh no, this person is very familiar but not named, or the person is unfamiliar. And then you say, how difficult was it to name them? And as a control, we present people with numbers on the screen, and they have to say whether they're odd or even. And we also have them name objects like this. For some people, this may be a more difficult name, a metronome, than the person that they were seeing. And again, they do the exact same thing. And we compare the parts of the brain that were activated for the objects, for the faces with the objects. And what we find for nameable objects is you get nameable faces, you get a large swath activated in the retrosplenial cortex, some part of the medial prefrontal cortex, because usually these things have some personal significance, and this region tends to be happy when there's personal significance. But you also get bilateral hippocampal activation in comparison to objects. For faces that you can't name, you still get lots of the face areas being activated, but not the hippocampus. The hippocampus is not, because these faces conjure up experiences, and that's what the hippocampus is interested in. So this is that study that Shlomo, Bentin, and I did in 1992. We were interested at that time, as many psychologists were who were studying memory, in implicit memory. How well do you know something without being able to actually say that you remember it? In other words, you could say, look, I don't remember seeing this, it's not there, but your performance belies your answers. In this case, what we did was present words to subjects that they studied, and then afterwards repeated the words, either once or twice. The subject had to make a lexical decision. Is it a word or a non-word? Often the subjects didn't remember or recollect having seen the word, but the reaction times were much faster to words that they saw than words that they didn't. And here we looked at their electrophysiological response, and what we saw was that words that were repeated twice gave a bigger N, actually around 500 to 600, a posterior parietal response greater than words that they hadn't studied at all. And we left this aside for a while. This is explicit recognition. This was implicit recognition. This is explicit. And we said that there must be some kind of common memory, both in implicit memory and explicit memory, that both draw on. In some later studies that I did, we found out that indeed, if you can recollect an event, you're much faster on these priming tasks. Recollected, that means imagine it in some detail. You're much faster on these priming tasks than if you can't recollect an event, that it's merely familiar to you, but nothing else. And we used famous faces. These would we call autobiographically significant events, just like the faces we talked about. Semantic concepts that are associated with vivid episodic memories, like a picture of Yitzhak Rabin. You both know who he is, you can have a lot of semantic facts, and you probably also have episodic memories associated with him. And these things are not easily accommodated by models of memory, of declarative memory, or models of semantic memory, because they think these two realms are far apart. We don't think so. So if you get the name Yitzhak Rabin, chances are both kinds of memories are activated. And we ask people about these names before they go into the experiment or afterwards. How many personal memories do you have associated with this individual? And here it could be one, if hardly anyone's, to 4 very vivid memories associated with them. In healthy adults, autobiographically significant concepts are associated with better performance on tests of semantic and episodic memory. In patients with semantic dementia, they will still show the effect because their hippocampus is intact, or not intact, but relatively preserved. Let me just move on to the results of the study. So we did this thing. This time the electrodes were placed in Toronto, actually in Ottawa, not in Toronto. And we looked at 2 waveforms, the N400, which is very sensitive to semantic memory. Oh, where is it? Oh, did I ruin both of them? No. Very sensitive to meaning, semantic violation. So for example, if you say he takes his coffee with cream and dog, the N400 is very happy. It'll say, woo, I got that. That's not right. You get a big N400. And you get lots of semantic priming effects here. The lateral parietal complex, a little later, is sensitive to retrieval from episodic memory and varies according to how recollective the memory was, how vivid it was in your mind's eye. So here's a task, just a fame judgment task. Tell me, is this person famous or not? This is a recognition memory task. Here you say, okay, did you see this name before in the experiment? How confident are you? And ratings of personal memories associated with this name. Do you have any personal memories or very vivid personal memories associated with Chuck Norris? Now, you might think, why would anybody in our experiments have personal memories associated with Chuck Norris or Woody Allen or Tom Hanks or whoever it is? Because your life, you may remember going to a movie with somebody very special at that time and you have a personal memory. Or maybe Chuck Norris was your hero in childhood and you wanted to be able to be a karate master the way he was. And we look at electrodes here that measure the N400 and the posterior parietal electrodes. So when you look at the high number of facts, how many facts could you mention about this person, not personal memories? You get modulation in the N400 region related to their semantic memory. So what happens here? If we ask the person to make a fame judgment and the name is of high autobiographical significance, the N400 doesn't pick it up. But the LPC complex does, and you get a very large effect over here. In recognition memory, it's the same way. Do you recognize this person, that you studied it in the experiment? And you get the same kind of effect with items that are high in confidence, giving a much higher effect here than here. Sorry, than earlier on in the waveform. The left posterior sites seem to track autobiographical significance. The greater the autobiographical significance of the event, the higher the confidence that you have for it, and the activation in the right posterior complex will show the same thing. It's correlated very highly with the autobiographical significance of the event and the confidence that you have in the memory. So, this is a study that I would have wanted to show to Shlomo, but couldn't. I mentioned it briefly to him when we were together in June, and it was over. But we now have evidence that indeed in ERPs, different parts of the complex will be active to different parts of will track different aspects of the memory for particular individuals, and also, we believe, for faces, which we're going to try later on. If you know a lot of information, but none of it is autobiographical, the N400 will really light up, or not light up, but you give it a large deflection. If you have autobiographical significance associated with a name, regardless of how much semantic knowledge you have about the person, then the LPC will show a much greater deflection. So the conclusion: some episodic memories are transformed with time from detailed representations of consciously experienced events to more schematic or semantic representation. To the extent that memories remain episodic, they continue to depend on the hippocampus, no matter how long ago they were formed. This is what Lynn Adele and I said in 1997. To the extent that they are semantic, they are represented in extrahippocampal, likely neocortical structures. Gordon Winokur and I elaborated on this transformation hypothesis recently. The two types of memory are in dynamic interaction from their inception. How quickly episodic memories are schematized and become independent of the hippocampus depends on the task and existing schemas. Reminders, as in reconsolidation studies that I showed you, and task demands can reinstate or recreate the episodic memories. So a memory that was once hippocampally independent can become hippocampally dependent again if you remind the individual of it. Let me end with two quotations that refer both to this research, I realize, and also to Shlomo. The past isn't dead. It isn't even past. I think it's hard for me to imagine that thinking of Shlomo won't be, maybe if not a daily occurrence, certainly every second day. Right now, it's a daily occurrence. One senses, because one has a hippocampus, that the person can be with you, even though the person is absent. And the second quote, it's a poor sort of memory that only works backwards. And indeed, we use these autobiographical memories, and I'll remind you of the quote that Shlomo said about Potok, that whenever I think of Israel and coming here, I'd think forwards and think that I would see Shlomo. And that memory, though, is there, will not be realized. Thank you very much. It's late. I don't know if you want questions or you think we maybe could call it a day. If anybody has any questions, I'm happy to entertain them either from the podium or when I leave it. Okay, thank you very much again. And thank you for inviting me.